In this video, I'll be manually controlling the water flow rate in this tank that you see here. I will be pumping water in the tank by using the pump, and but the pump will be pumping water at a constant flow rate. However, what I will be controlling is the flow rate entering the tank by using my pneumatic control valve. So I'll be manually controlling it with the calibrator and with the reed calibrator that you see here. So I'll be manually controlling the flow rate entering my tank. And in this experiment is to show you that for each flow rate, for each valve position, the flow rate will change, of course, but what also will change is the level of water in my tank. So in order to allow the level of water in the tank to stabilize for each valve position, I need to have an escape route for my water. My water has to drain out of the tank at some rate. Otherwise, the water will just enter the tank and will go all the way up and it will stop there. So there has to be an output flow rate, and I will leave hand valve for halfway open. So right now it is fully open, and I will make it halfway open, and I won't change this position. So this is approximately halfway open, so I won't be changing that position throughout this experiment. And this is to show you that as the flow rate changes, the input flow rate changes by changing the valve's position, the pneumatic valve, the water level will stabilize at some specific position for each valve position, pneumatic valve position. So I will start pumping water in the tank to show you how the water level will stabilize at some specific position for each valve opening. So right now I have, you can see here, a reading on my reed calibrator. I have 4 milliamps. So 4 milliamps is going into this pneumatic valve, and therefore the valve is open, is fully open. And I will allow water to enter my tank. So we have to wait a few moments, and we will see that the water will stabilize at some position. The water continues to rise, but I think we're getting very close to the stable position. Looks it's stable right now. Approximately 25. maybe 25 centimeters. $25.5 maybe. So it did stabilize at around 25.5. One hand valve, so the hand valve, I'm not going to change it throughout this experiment. It's halfway open or halfway closed if you like. And for the pneumatic, when the pneumatic valve is fully open, the water level stabilizes. It does stabilize, so we know it's approximately 25.5 approximately. And now what I'm going to do, I'm going to change the position of the pneumatic control valve. So I'm going to increase it. So it's 8 millimeters right now. Doesn't look like my water is rising too much. So what I'll do, I'll increase it a little bit more because maybe maybe it's not going to be visually possible to see what. Actually, yes. So now we're seeing a drop. Okay, we're seeing the water level drop. So obviously the water is going to drop because the input flow, or the flow that is going in the tank has been reduced, and so all of a sudden we see the water level drop. But I think it should stabilize and not totally empty. Hopefully. Because if the output flow is higher, then I'm afraid that it's probably not going to stabilize and just completely drain out. Still dropping, I think. Just have to be a little bit patient for this to stabilize. If the input flow is lower than the output flow, I'm afraid that the tank will just empty out and will not stabilize to a specific level of water. And that's what would happen in this case. I should say in that case, because I'm not sure if this is the case that we have. It looks like it's stabilized to 11. It looks like it's stabilized to 11. When I have 12 milliamp input, the level of water is at approximately 11 centimeters. Okay, so with this type of setup, I have a what is called a self-regulating process, meaning that for each valve position, for the pneumatic control valve, at least from 4 all the way to 12, the level of the water does stabilize in my tank. And now what I would like to do is show you that I could further close the pneumatic control valve, and then but the problem is that by controlling it even more, by closing it even more, the tank will simply be totally empty, and by doing that, it will be difficult to control the valve. It will be difficult to control the level of water in the valve beyond zero. So that's not a process, a self-regulating process that would allow you to control the level of the water beyond zero. So there's another thing that could be controlled in this experiment. For each valve position, you could also control the pressure of water above the pressure of air above the water in this tank. So there are two things you could control with this type of setup. Although I'm doing manual control, but you could also automatically control not only the level of the water, because it is self-regulating to the at least from 4 milliamp to 12 milliamp input from the calibrator, by adjusting the pneumatic control valve position with the calibrator from 4 milliamp to 12 milliamp. It's possible to have the water level stabilized at some position. There's also another thing that could be controlled is the pressure of air above the tank. So this tells me that it is self-regulating, both the water at the bottom of the tank and the air above the tank for different positions of the pneumatic control valve. In another video, I will show you how what a non-self-regulating process looks like.